Let's learn about how to build agentic RAG architecture. So now this is the code. For example, based on the code I have written, I'm able to develop an UI around the agentic RAG, where exactly means it's a simple use case where exactly we are able to build an agent or an agentic RAG. So now I'm able to browse and I can upload a file. It can be my agenda or whatever it is, course agenda. If I upload course agenda, I want to process this particular PDF where we are creating the vector store and all this kind of thing. We are creating embedding, we are creating vector store and all of this. And once we create it, now we are able to launch our agentic RAG, or we are able to launch our agentic chat. And here I can start asking the questions, maybe like what they are covering in this course, for example. And when we are able to ask that question, so it is able to start giving a response. So now you can just think, hey, like Kant, like we know RAG architecture. So in a RAG architecture, let's try to understand. Meanwhile, as it is generating the query, now here, if you are able to see, there is a RAG architecture. So what we do in a RAG architecture is, so whenever a user is asking a query or a question, so now we are able to take that query, which is the question asked by a user, we are able to call it as prompt. So like based on our user prompt plus a system prompt, and based on that prompt, our LLM model going to search for a similar document. Then saying an LLM document, we are able to call it as retriever. So like this retriever going to search the particular vector store, and it is able to collect the similar documents or the similar chunks from our document. So now for that, in order to create a chunks, in order to store it, we need to have a vector DB. And in order to perform search on top of it, yes, you need to have that embedding. So based on embeddings, you are able to perform vector DB. So within that vector DB, you have your search similarity. Basically, it's a search similarity equations or kind of Euclidean distance equations or a kind of cosine similarity equations. So it is able to get a context. So it is able to retrieve a context. So based on the context plus the prompt, from the user, based on that we are able to feed that to an LLM model, large language model. It is able to provide a response, it is able to give an output. And if you are able to take an AI agent, so what an AI agent going to do, whenever you are asking a question, instead of generating a particular response, the agent is connected with various tools, or this LLM model is connected with various tools. So like it is able to perform an action for us, it is able to do an action, or it is able to do a task for us. So now it is able to run a code, or it is able to create a PDF, or it is able to maybe like create a reminder in my calendar, or it is able to send a message in a Slack channel. So like we are able to do that with the help of an AI agent, or we can say agentic AI. And now with the help of agentic RAG, what we are doing is, now we are able to get the data, we are able to get a context from your RAG architecture or from your external document, and we are able to, based on that external document, the agent is able to plan a better action. So like there are various things connected within your, what is that, within your agent. So there are multiple agents. So there is a planner agent, there is an execution agent, there is a tool agent. In this way, there are different types of agents. Now in order to plan it, in order to reason it, in order to plan the steps, what exactly your AI agents can do is they are able to take, or they are able to leverage this external document, or they are able to leverage this context. So that is the difference between agentic RAG. So now a regular agent going to do an action, but in order to do an action, you are, in order to reason it, in order to perform certain task, or in order to do, or in order to plan it, we are able to provide an external document, not just for the sake of giving a response, but even in order to plan it as well, we are able to give an external document. We are able to call it as agentic RAG architecture. So within this agentic RAG architecture, yes, whenever you see an agent, you have various blocks. You are able to have a memory layer, you are having a planning layer, you are having a tools layer, you are able to have your LLM layer. In this way, you are able to have different layers within your agents. So now this is what you are able to see. Now, in an agentic RAG architecture, what we are trying to do is we are able to provide an external document to it. Now that the same thing I'm doing it, if you see here, now we are providing an external document. Based on the external document, based on the curriculum we have it, it is able to provide me the response. It is able to give me a response. Now, the goal is not just to provide a response. The goal is maybe like to create a, means like calendar channel, or it need to resolve certain coding stuff, or whatever it is. It need to do certain actions, or it need to write on a Python code based on the course agenda. So if the goal is to perform an action, yes, we need to go with the agentic RAG kind of thing. In order to have the planning better, in order to have that actions better, yes, agentic RAG going to be one of the best option. Now, how exactly we coded this is, if you are able to look into the backend code of it. Now, these are the various elements. Now, the major three blocks going to be agentic RAG graph, where I'm using lang graphs, where I'm using lang chains, where I'm using Streamlit, tick token, and all of these elements. And I'm using app.py, where you got your Streamlit or the front end layer or the UI layer, and you are having this utils.py, where you are having your basically creating of your taking a document, and from that document you are trying to create chunks, and from that chunks you are creating embeddings, and from that embeddings you are passing that into a vector store, so that whenever a user is asking a question, it is able to retrieve us this similar document. So that's what the utils is doing. And this is the code all is about utils, means in order to get your means like the finalized document. That's what you are getting it from utils.py. And through agentic RAG architecture, so you are building an agent. So like you are building a, if you are able to see the simple idea, you are trying to build an embedding, OpenAI embeddings we are using vector store. So whatever the data, means whatever the PDF we have it, we embedded that into the numbers, and that numbers, in order to perform a search similarity, you need to have a vector store. Yes, you have a vector store. And whenever a user is asking a question, it need to perform maybe a cosine similarity, and it need to pull out the similar documents. For that, you need to have the retriever. And then we are creating a retriever tool. For example, if you see your agentic RAG architecture, so now you are trying to build all of them as the tools. So now you are trying to create retriever tool. So what exactly this retriever tool going to do? Whenever a user is asking a question, based on that, it is able to retrieve the document. So like basically it's a function. So tools in your agentic AI are nothing but your Python function. So now it's a tool. And then you are trying to take an LLM model, and then you, in order to maintain the conversation, or in order to maintain the chat history, you are trying to use conversation buffer memory, and then you are trying to create a small prompt template, and then you are trying to create an agent where exactly you have your retriever tool, you have your LLM model, you have your prompt engineering, whichever you have done it. So that is called as an agent. Now this contains only retriever, but you can add multiple agents as well. I can add a planning agent, I can have an execution agent. So like I can have a reasoning agent, I can have multiple agents, and I can collaborate them. We call it as multi-agent architecture, or we can say multi-agent agentic. So you no need to say multi-agent agentic RAG, you can simply say agentic RAG or multi-agent. And then you are able to use your executor. So what exactly executor is? Now you created an agent. In order to run that agent, you have an executor. So like, which includes even the memory for that particular agent. And then in order to orchestrate this particular agents, we are using lang graphs. Basically, if I want to orchestrate it now, lang chain is used to define your structure, and in order to orchestrate it, so when to do it. So like we can define that with the help of lang graphs. From here, we are defining lang graphs code. So this is your actual brain. So utils contains only your vector store, retriever, and all this kind of elements, whereas RAG, agentic underscore RAG underscore graph, contains your entire development of it, and lang graph major purpose is to orchestrate it. And once it is done, to interact with the UI, you got your app.py, so that going to be your UI, you are able to see this. Now, with the help of app.py, I'm developing the Streamlit UI, and we are connecting everything with your backend. That's what we are basically doing here. Now, this going to be our front end. This is going to be our front end part, where exactly, if you are able to run this, we are able to get the front end part. So this is going to be my front end part, where we are able to get a simple agentic RAG. Now this is a very simple agentic RAG. On top of it, you are able to make a multi-agent and all of this. So now the difference between RAG and agentic RAG is, in a RAG architecture, if you are taking an external data, feeding into an LLM model, we are able to get the response in a RAG architecture. Whereas in agentic RAG architecture, you are providing an external data, you are feeding into an LLM model, and you are able to get an action. The goal is not just a generation, the goal is to get an action. And even this action can be more informed or more context driven, so that this agentic RAGs are getting more popularity or traction in the industry. As simple as that. I hope you got a simple idea about what is RAG and what is agentic RAG. If you want to know more about it, so like you can can check about RAG architecture, agentic RAG, or you can just get into my course where exactly we'll be going deep into this agentic AI, agentic RAG, MCPs, LLMs, LLM ops, and all this we will be starting from scratch, and we'll be working on means like industry ready based projects. So in case if you want to know more details, you can just drop your, it means like you can reach out to us. The links are in the description.